This is a variable-driven set theory Venn diagram set. Now, in these kind of sets, I've explained in our classes and lessons and also in the live webinars, the center region is a very vital region. Try to hit on it because although you have variables tested, if you hit on the center region properly and then try to relate the information accordingly, this becomes a little easier to solve. Otherwise, these kind of sets typically becomes a little difficult to analyze, or you'll be too much into equation solving and everything. In this set, for an example, you have been given the number of servings of all three is B, C, and S. But before you get into those additional information, let me overlay the premise and the context here once before we start off. So we have the 1600 satellites that are sent for several purposes, whatever. So these are mainly the three purposes: broadcasting, communication, and surveillance. And others is a different thing. Now it says the satellite can serve multiple purposes. However, satellite serving B or C or S does not serve O. So this is very vital because now it's a not a four-side Venn diagram, it's a three-side Venn diagram. Anything that is serving B or C or S and or a combination of their, these purposes will fall outside the O region. So implying that if I take three circles for B, C, S, O will be the outside region. So let us go ahead with that. So I'll just draw a small Venn diagram here because I have a feeling, depending on the information, that there might be a requirement for another Venn diagram, a simplified version. So after, I resolve the relation between the variables and regions and all. So everything is 1600, that is known to us. So this is B, this is C, and this is S, let's say. And outside region is O, so I don't need to mark that. Now, what are the additional information that we have? So as I said, always hit on the center region first, if possible. So point number 2 is telling us that the number of satellites serving all three is 100. So this is a numerical information, good enough. So this is directly given. It also tells us, the first information tells us number of satellites serving B, C, and S may not exclusively imply the B circle total, C circle total, and S circle total. So that is 2:1:1, right? So the B circle, the C circle, and the S circle. So these three are in the ratio 2:1:1. So let me keep this outside. So we know this relation 1. What else do we know? Third one tells us, so 1 and 2 are done. Third one is saying, the number of satellites exclusively serving C is same as the number of satellites exclusively serving S. This number is 30% of the number of satellites exclusively serving B. So what does exclusively means? Only C, only S, only B, right? So the only C and only S are equal, and these two are equal to 30% of this number. So implying that this and this are in this ratio. So 10:3:C. So if this is 10, then this is 3, this is 3. So I'm not writing 10, 3, 3 as the values. This is the ratio. So better way to indicate that will be just to consider that this is 10x, this is 3x. Sorry for that. And this is 3x, right? So these are the relationship between these three regions. So 30% of 10x, that is 3x. So this third point is taken. Now coming to the fourth one and the last one, the number of satellites serving O is same as the number of satellites serving both C and S, but not B. So O is the outside region, right? So let me put a tick mark to relate these two first. So the outside region is equal to the one serving both C and S, but not B. And that is this region, isn't it? So these two should be having the same value. Now, also another thing, C total, the C circle total and the S circle total should be equal, right? Implying, now check this out. This region is anyhow common between C and S, right? And you can see that only C and only S are equal. So if the C total and the S total are equal, implies that this region and this region should also be having equal value. Only then it is feasible, right? They are in the ratio 1:1, the C total and the S total. So let us now indicate them by some variable. So I know a couple of things now, and let me mark these things. So let us say this is Y, and this is Z, and this is Z. I typically give the analysis at the last part of the set, but for this point, I'll give you the analysis straight away. Whenever we are having these many variables in the relationship to indicate the relationship that are given, you can take a call to solve this set later on, because till this point it will take you roughly 3 to 4 minutes to reach this point if you read it properly and understand these kind of things properly. So the comprehension ability is definitely important. So if you reach this point in 3 to 4 minutes, you can take a call to leave this for a later part, so not solve it right away, because you should have a feel that this might take a bit of time. So later on, if you're not getting a set to solve and then you have come back to this, you have these information collected, right? So whichever rough page you are calculating this on, so leave this page and maybe the next page to resolve this, and then move on to the next set. So that will be one strategy you can go ahead with, provided this type of set comes at the initial part of your paper, or the section rather. So that was just the analysis that I wanted to provide. Now let us move into the solution of it. Now the only other information that we have is this thing, right? So this 2:1:1. So this is the only way we can connect these variables. My target will be to come down to at least a single variable, if not possible to resolve the whole thing. But before we do that, I have those things in mind. Let me have a check into the questions, because depending on the questions that are going to be there, I might approach it in a different manner. So let me get into the questions for a minute now. So if we go through the questions quickly, look at question number 5. What best can be said about the number of satellites serving C? Options: must be between this, cannot be more than, must be at least this much. So some sort of range, right? Question number 6, what is the minimum possible number of satellites serving B exclusively? So again, if you're talking about minimum, that has to do something with a range. If at least 100 of the 1600 satellites were serving over, what can be said about this thing? Even in the options, there are a couple of information like at least, at most. So again, something related to range, maybe. In this case, we have an option like C also, which is exactly 475, and obviously B, which is no conclusion is possible. But we'll come to those kind of things in a while. But again, something to do with range as well, right? D says if the number of satellites serving at least two of this is 1200, which are the following must be false. So this thing is, again, few of the options like more than 1000, but then not all of them, but this might be a very crucial information to rule it out or get it down to a particular solution. So but we get a feel now that the solution or the type of solution that we are going to get will not be a specific value, but will be a range sort of value. So whenever we have a range sort of value, that has to do with some variable existing in the Venn diagram. So there has to be at least one variable remaining. So that should be our target. So we'll try to resolve this down to one variable instead of having all these variables. So my target will be to get it to the variable x, because this 10x, 3x, and 3x seems to be a good numerical this thing. Doesn't involve fractions. So if I try to get into some other variable, that might involve a bit of fraction later on. So let's not go into that. So this is the one I'm going to use to combine and get it down to the single variable, that is. So let us do that. The first thing, the B total. The B total is 10x plus couple of z's. Let me write it a little bit left, say. So we have 10x plus couple of z's plus this 100, and that should be double of C or S, right? So C or S anyhow, which will be equal. So if I use that, so we have something like double of 3x plus y plus z plus 100. So this is what we have, right? So this is for the first thing, the B and C relation. So let me try to do that now. So what we have is 10x plus C. The 2z is cancelling out, right? So this 2z, not this 2 should not be cancelled out. This z is, even I hope you understand what I'm doing. So 2 into z. So that z gets off and out of this 2z. And whatever x and y we have, so let us get it in the same, this thing. Let me keep the x on this side. So 10x minus 6x is 4x. I'm trying to keep the y on positive, so I'll keep the y on the right side. So 2y, and the constant value is 2 into 100, 200 minus 100. So that is 100 on this side, right? So as I said, I'll get everything. I'll try to get everything in terms of x. So I'll put in y in terms of x, right? So I'll put in y is equal to 2x minus 50. That is what we have, right? So just halving this and taking the 50 on the left hand side. So we have y is equal to 2x minus 50. Now y is understood. So y we have got. What about z? So z I have to figure out in terms of x, right? So if I use again b is twice of a, so that doesn't help me because the z and z we obtained by equating this one and one, right? So that is useless now. So what else can we do? We can think about the total. We have the grand total with us, right? So we have the grand total as if you think about all the x's that we have. So we have 16x in total. We have couple of y's, we have couple of z's, and we have this 100 adding up to 1600. So if I eliminate the 100, so I'll have a total of 1500, right? So this is what we have. And also that y is equal to, or you can check this directly, 2y is 4x minus 100. So we can substitute that. So if I substitute 4x minus 100 in this spot, so 16x plus 4x will be 20x. You have that minus 100 plus 2z is equal to 1500. So now we can get z in terms of x, right? So we have z is equal to, let me show you how we can do this mentally. So minus 100 goes this side is 1600, half it, so 800. And the 20x goes on the negative, on the other side, right hand side, so goes in negative form. But then you half it as well because 2z has to be halved. So minus 10x. Or you can write those steps, you'll get to the same point. So these are x and y in y and z in terms of x. So let me draw another Venn diagram. So what I'm going to do is I'm going to just substitute this y and z with x. That is all I'm going to do. So I'm going to do this in this Venn diagram itself. But ideally, you should be. I'm going to do this in the same Venn diagram itself. But ideally, you should be doing this in a different Venn diagram. But I have a lack of space, so I'll do it in this Venn diagram itself. Okay, so now that range thing that I was talking about. So this is an interesting trick. I mean, I have discussed this in our classes. So whenever we have this various regions in Venn diagram and you have a single variable, it's very easy to find the range. The idea is all the regions independently should be non-negative numbers, right? You cannot have a negative region. So for instance, this 2x minus 50 should be non-negative. Similarly, this 800 minus 10x should also be non-negative. So these are primarily the two regions that we'll focus on because there are couple of 2x minus 50 and couple of 800 minus 10x. And the 3x, 10x is not going to tell me anything about the range of x. The reason being, just check this out. I mean, this is something I'm not going into too much details. I've anyhow explained in our classes, so our students will anyhow understand this. So if you look at this part, 2x minus 50, so this 2x minus 50 should be greater than equal to 0. This sort of regions or x minus something region. So these sort of regions will always give us the minimum possibility of x. So x should be greater than equal to 25. Just resolve this. That's 50 on the other side and then divide by 2. So this is giving me the minimum possibility. And if you take the other one, 800 minus 10x is greater than equal to 0. So 10x goes into the less than equal to side, right? So this will get transmitted to this side. So this 10x goes to the right hand side. So 10x goes to the less than equal to side, 800. So x is less than equal to 80. So now if you combine these two, see you're getting a range of x, right? So we are getting a range of x as lying in the region of 25 to 80. Both inclusive, of course. So this is the range of x. So as soon as we get this range, we can now figure out these kind of questions very quickly. So let us go ahead with the questions now. Question number 5 asks for what best can be said about the number of satellites serving C. So number of satellites serving C is this entire total. So let us quickly get this total in terms of x. So we have 100, 800 and minus 50. So add the constant separately. So 100, 800 and minus 50. So that is 850. And in terms of the variables, we have a 3x, we have a 2x, so that is 5x, and then minus for 10x, so that is minus 5x, right? So this is what we have as C total. So C total is this much. And now if you include this range, so if x is 25, then this value is 850 minus 125, right? So if x is 25, that is, this value will be 850 minus 125, which is 725. And if that itself will answer this, because when x is minimum, this will be maximum. But anyhow, let me just show this completely. If I pick x as 80, the other extreme, so we will have 850 minus 400. which will be 450. So X being lying in this range, C will lie in 450 to 725. So must be between 450 and 725. This should be inclusive of both, but anyhow, that is fine. So that is for question number 5. Question number 6 is, what is the minimum possible number of satellites serving B exclusively? Now, B exclusively is served by 10x, right? So 10x minimum will happen only when X is minimum. So X minimum is 25, so 10x minimum is 250. So this is again very simply figured out. So 10 is option C. 7 says if at least 100 of the 1600 satellites were serving O. So this is an additional constraint. It tells us that at least this 2x minus 50 value is at least 100, right? So 2x minus 50 is at least 100. So this is what we have. So this modifies the range of X maybe. So let us look at this. So what are we getting? So this is 150 on that side divided by 2. So X is greater than equal to 75 now. So that changes the range a bit. So we had earlier X greater than equal to 25. So now we have X greater than equal to 75. So this converts to something like this, right? So this is a modified range of X now. And what are we looking for? What can be said about the number of satellites serving S? So I should not have erased that part. It's the same total. So you can go ahead and do it once again. So that's 800 plus 100 minus 50, 750 minus 5x. So that was for S, because C and S, if you remember, are the same total. So that is what I was saying. I mean, in your rough books, you will never have this problem because C will be written for you. So this is for S as well, right? 750 minus 5x. So we are looking for this part, and again plug in those values. So if you plug in 80, then this value comes out to be 450. That is known from the first question's answer. And also if you plug in 75 here, so 5 into 75 subtracted from 750, you can check this out. I mean, you can do it whichever way. I would prefer to do it in this way. This is a little smart technique. Because I'm reducing X by 5, 5x will reduce by 25. So this 750 minus 5x will increase by 25. So this is 475 maximum. So we are having a range of 450 to 475. So at most 475, right? So option D is the correct one here. That is for question number 7. Now moving to question number 8. Now this is a fixed kind of information. So let us look at that. Just let me take this part off now. It says that if the number of satellites serving at least 2 among B, C, and S. So what is the at least 2 part? First, identify those regions. At least 2 is this, and this, right? Even all 3 is at least 2. So what are the totals here? So a couple of 800s, then you have 100, and then you have a minus 50, right? So 800 is 1600, plus 100 is 1700, minus 50 is 1650. So we get a total of 1650 in terms of constants. And in terms of X, we have a minus 10x, so that is minus 20x, plus a 2x, so that is minus 18x. So this is the at least 2 part, right? We could have done the other way around. We could have taken the other 4 regions, but that is also 4, this is also 4, so it really doesn't make any difference. So if the number of satellites serving at least 2 is 1200, so this is exactly 1200, right? So this is equal to 1200. So that will fix us a value of this X, right? So we can just equate this. So if you just solve this, 18x is equal to 450. So 9x equal to 450 is X equal to 50. So this should be 25, right? Or you can take the steps as well. So X is equal to 25. So this is the lowest possibility that we are talking about. X is 25, if you remember. But that is not relevant that much. We are getting a value of X equal to 25. Which of the following must be false? So we have to individually check the options now. Now, A says that all 1600 satellites serve B or C or S. If all 1600 are serving B or C or S, so the outside region should be 0. But if X is 25, then the outside region is actually 0. So this is a correct option. So that is not must be false. So this is actually must be true. So eliminate that option. B says number of satellites serving C cannot be uniquely determined. Everything can be uniquely determined in this case. Because since we have all the, the X is fixed and every region is in terms of X or a constant value. So every region can actually be uniquely determined. So option B is incorrect. We can actually determine everything in this set. Once we have this value of X. So that is it for this set. Initially, I gave you a bit of analysis. I'll just end it up by saying the total time that it should take. If you solve this very smartly and very with a cool mind, it will still take you somewhere in the range of 11 to 12 minutes to solve this set, because you have that initially in terms of information. The gathering part is still fine. If you are not very confident to solve using those variables, you try to avoid the variables, then you will jumble up yourself a little bit more. You'll waste too much time without taking those variables. So it's a good habit to indicate by variables and then figure out whether those variables are required to solve it or not. Sometimes it will not be, but just for the visual representation, you have those variables in front of you, you can relate it. But later on, you identify those variables are not required to actually solve it out, but always indicate that first. But don't avoid it straight away. So that will be a bad idea. Few things, subtle hints here and there, you have to catch them. For example, that C and S were equal, so automatically that ZZ link that I was getting. If you understand those things, then it becomes a little faster to solve. Apart from that, still, I would say it will take you somewhere in the range of 11 to 12 minutes. So it is definitely an intense level of difficulty. It's not an easy set to solve. And hence, as I was saying, I mean, whenever we have three variables in a Venn diagram, typically those kind of sets are not very easy to solve. So you should leave this for a later part. If you have no more sets to solve, then up to the extent that you have solved, if you are very, very well adept with Venn diagram solving techniques, then come back to the set and solve this. That's it for this set. Nothing more to add to it. Hope you had fun. Thank you.